Okay, welcome back, guys. As promised earlier, that in this video we'll be having calculations on electron drift velocity. So here we want to see how we can easily calculate the electron drift velocity without taking much of our time. We just need you to be very much familiar with each of these terms that we use in the formula. Now remember, we started with two formulas. The first one is said to be Evans dad over what? My mommy, and that is equal to our what? Is equal to our current. And the second formula we have is that your current is still the same thing as even over what? Over Lovett. We stated that you use the second formula when your density is not given. So let's state out each of the factor or parameters that have been given in this formula and see how we can easily calculate without wasting much of our time. The first one that has been given here, they said a cylinder of fluid contains 4 times 10 to the power 24 sodium. So this is the number of atoms. This is the number of atoms. You have to be n. The number of atoms is 4 times 10 raised to the power 24 atoms. Okay? 24 atoms. 4 times 10 to the power 24. Sorry. That's for the number of atoms of sodium, of which are the only charge carriers. The dimension of the cylinder are 20 centimeter long. The length is said to be what? 20 centimeter. But you know that you have to convert this to what? To meter, and that will be what? 0.2 meter. Okay? With the cross-sectional area of radius 5 millimeter. So to get we have been given the radius, and the radius is said to be, that is 5 millimeter. If our radius is 5 millimeter, we can convert to meter, and that will be what? 5 times 10 raised to the power, that is 3 minus 3 meter. So to get the area, that's very simple. We know that the area of the cross-sectional area is what? Pi r squared. So to get that, we say 22 over 7, where our area is equal to 22 over 7 times our radius. What's our radius? Radius is said to be 5 times 10 raised to the power, what do you have it as? Minus 3. You know you have to square this, right? Now, squaring this, now what do you get as your area? What's our area? This should give us 22 times, 5 squared should give us 25 times 10 raised to the power minus 6 times 10 raised to the power minus 6. Everything over that is 7 over 7. So what do we have as our area? What do we calculate as our area? Let's see what we calculate as our area. Using our calculator, we get 7.86. That's 7.86 times 10 raised to the power minus 5. That is in meter square. Your meter square is your unit. Hope you know that. So we've been given the number of atoms, we've been given the length, we've been given the radius, we've been given the area. We say these are dimension, and the current of our calculation now, the current passing through now is what? Is said to be 5 ampere. Now what they say we should calculate, you have to calculate the drift velocity. Now the question is, are we to use Evans dad over my mommy, or we using even over Lovett? Remember, if you are not given your density, you use even over what? Lovett. Don't forget, your I is what? Current. Your E is what? The electric charge of electron. We have V to be our velocity. That VE, that is V substitute. E is our velocity. That N, that last N, is the number of atoms. And I told you that this number of atoms is not the same as your what? Avogadro's number of atoms over L. L is your what? The length. So let's quickly get this out using our direct method. Now, I as said earlier, using this formula now. So this is the formula we are using. I as said earlier, what's our I from this expression? I is equal to 5. E is the charge of electron, and you ought to know this, that your charge of electron is always what? 1.602 times 10 raised to the power minus 19. Don't forget that. Now times your drift velocity, VE, times what is your N? N is your number of atoms. What do you have as number of atoms? That is 4 times 10 raised to the power 24. All over, what is our L? L is our length. And what do you have as the L? Length, 0.2. We all know that when we cross multiply, we have it already to be what? That is 1 is equal to, what do you have this to be? That 1.602 times 4. When you say 1.602 times 10 raised to the power minus 19 times 4 times 10 raised to the power 24. Let's quickly multiply these two together. Yeah. Okay, using our calculator, we actually get 6.4 times 10 raised to the power 5 velocity over velocity. Now, we've gotten this. You know, you divide by the coefficient of the factor you are looking for. We are looking for VE, isn't it? And the coefficient is what? 6.4 times 10 raised to the power 5. So we easily divide with 6.4 times 10 raised to the power 5. We divide both sides by 6.4 times 10 raised to the power 5. Now this, we cancel this. Your drift velocity is equal to 1 over 6.4 times 10 raised to the power 5. And what do you have? 6.4 times 10 raised to the power 5. Let's do the velocity to be 1.56 times 10 raised to the power minus, that is minus 6 meter per second. That is our drift velocity. So it is very, you can see the working to actually calculate your drift velocity is just taking you how many steps? Just about 3 steps. Using this formula alone, you get what you need. So you don't need to follow some kind of lengthy step looking for one thing or the other before you get your drift velocity. It's just straightforward. You can try this with as many as possible questions, which you're going to do now. You can try this with as many as possible questions. You always get it right. Don't forget, whenever you're not given the density, there's an alternative formula for it, and when you are given density, you follow this method, this particular formula. Just know what it entails. Let's take another question. Just like the first question we solved, we're going to solve this in the same way. So let's just bring out the parameters first. A copper wire of radius 2 mm. So this one is having a radius of 2 mm. Just know that this radius should be taken to the wall. That is 2 times 10 raised to the power minus 3 meter. You divide by 1000. You divide by 1000 in order to convert to from millimeter to meter. Okay, and it's having current of 10 ampere passing through it. There is one conductive electron per atom. Okay, the density of copper is 3.94 times 10 to the power 3 kg per meter cube. So we have now that the density is equal to what? 3.94 times 10 to the power 1 times 10 to the power 3 kg per meter cube. Now let me give you this hint. It will be difficult to solve using this the unit of this density directly. It is always advisable that your density is in gram per meter cube. That is gram per meter cube, not kilogram. And it's very easy to convert. What is K? Whenever you see K in a unit like kilowatts, this K here or kilogram, in order to convert to their respective unit, that is what you have after it, which is watt, or you are converting to what? You are converting to gram. What you just do here is that your K represents 1000. So it means that you multiply this by 1000. So when you multiply by 1000, what is it going to give you? Your D will become 3.94 times 10 raised to the power what? 3.94 times 10 raised to the power 6 gram per meter cube. So we have just converted to what? We have converted to gram per meter cube. Okay, let's get the other parameters done. Here we have the molar mass to be what? What's our molar mass? That is our molar mass. M is said to be 64 gram per mole. 64 gram per mole. That is our monomie. Okay, but since we've been given radius, we can easily get our area. How do we get area? You already know that cross-sectional area is what? Pi r squared. So don't forget this formula. What's pi? Pi is just 22/7 times, what's our radius? The radius is 2 times 10 to the power 3. So you have to be times 2 times 10 to the power 1. So we have to square this radius. When you square it, what do you have as your area now? We have to do 22 times. When you square this, it will give us 4 times 10 to the power minus 6. Everything divided by what now? Divided by 7. So let's get the value to this. That is 88/7 divided by what? 88/7 times 10 to the power minus 6. That is times 10 to the power minus 6. That is, we have that's 12.57, and approximately it can give us 1.257 times 10 to the power minus 5 meter square. So that's for our area. Okay, let's come back to the formula to use. These are just the parameters that they gave us. These are the parameters given. So now we have our density, and so once you have your density, don't just doubt it. Use the Evans dart over what? Monomie. So here we have that our current is equal to Evans dart over what? my mommy. Please don't forget, what's our current? From expression given here, current is 10 is equal to Evans. E is what? I've told you that you must not forget E is your what? Electron. That's 1.602 times 10 to the power what? Times 10 to the power minus 19 coulomb. And you have your that is number of atom. That is number of atom. Avogadro's number of atom is 6.02 times 10 to the power what? Times 10 to the power 23. Okay. E is 1.602 times 10 to the power minus 19 times V. V is our drift velocity which we are looking for, times area. We've gotten our area to be what? 1.257 times 10 to the power minus 5 times what do we have as NS? NS is our Avogadro's number of atom. That is 6.02 times 10 to the power 23 times what's our D? D is our density. What do we have as density? 3.94 times 10 to the power 1 times 10 to the power of what? 6 times 10 to the power 6. Everything over what? Your my mommy. What's your my mommy? My mommy is what? The molar mass, which is 64 over 64. Okay, let's cross multiply. We have this to be 640 when we cross multiply. Because now just multiply all of this nonsense together to get your answer. So let's use our calculator. We have 1.602 times 1.257 times 6.02 times 3.94. And we have this to be 47.76 times 10 raised to the power 5 over that is raised to the power 5. That is V. What's our V? Our V is the velocity, the drift velocity we are looking for. So what do we use to divide? You divide by the coefficient, which is what? 47.76 times 10 to the power 5 divided by 47.76 times 10 to the power 5. So this will cancel this. We have your drift velocity is equal to 640 divided by 47.76, and that will give us 13.4 times 10 to the power minus 5, and that will give us 1.34 times 10 to the power minus 4. This is the value of our drift velocity. This is our drift velocity. So whichever case you're given a question, just know the formula to use. Pick any of this formula and I assure you that you'll be able to get your drift velocity. Okay, let's solve another question. This is another question now. So we're going to pick out the parameters as usual and we'll determine which of the formula we are to use. Okay, here now, a copper wire of cross-sectional area. Area has been given straightforward here. What's our area? Our area has been given to be that is 3 times 10 raised to the power minus 6 meters squared. So there's no need for you looking for the area. You have been given directly. Then here we have that it carries a current of what? 10 ampere. So the current here is what? Is 10 ampere. Assuming that each copper atom contributes one free electron to the metal, okay, find the drift velocity of the electrons. Now other factor or other parameters are also stated here. This is the density. The density of copper is said to be this. So the density D is equal to what? 8.95. Here we have to be gram per what? Cm cube. Now remember what I told you that your density is always expected to be in what? Gram per meter cube, not cm cube. Per meter cube. Gram per meter cube, not cm cube. So how do you now convert your cm to m? You divide by 100 by 100 by 100. That is divided by 1 million. So when you divide by 1 million, it will definitely change to what? It's changed to 8.95 times 10 raised to the power 6. No, million is power of 6. So we have to be gram per what? M cube, not cm cube. So we've converted that. So here we also have that our Avogadro's number. What do you use to represent Avogadro's number? That is NS. You use NS to represent Avogadro's number. And we'll be given to what? 6.02 times 10 to the power 23. The last parameter given here, okay, the second to the last, the molar mass of copper, which is my mommy, as usual. Molar mass here is what? What's our molar mass? Our molar mass here is said to be that is 63.5. 63.5 times gram per mole 63.5 gram per mole. Then the last one here is the charge of electron. The charge of electron, which is what? The charge of electron, which is E. The charge of electron is said to be what? 1.6 times 10 to the power 1 times 10 to the power minus 19. Assuming it's not stated, you just use your 1.602 times 10 to the power minus 19 as you always do. Okay, now it's stated at the parameters. What are we to use? Is it this formula or this formula? Don't forget, these are the formulas that we can use basically to calculate for the electron drift. So which one are we using? Is it Evans dad over my mommy, or we are using even? I know you've gotten the answer right, which is Evans dad. Why? Because we're having our what? We're having our density. So let's use the Evans dad as usual. What's the current here? The current is said to be 10. So we are using 10 as our current. Our current is 10. We have V. V is our what? That is the velocity. E is what? E is our electron. That is 1.6 times 10 to the power what? That's 10 to the power minus 19. And what do you have as our V? V is unknown. That's what we're looking for. We have A. A is our area. Area is said to be 3 times 10 to the power what? That's 10 to the power minus 6 times N. NS. What's our NS? 6.02. 6.02 times 10 to the power what? 23. 6.02 times 10 to the power 23. What is the remaining one? D. These are what? Density. What have we gotten as our density? 8.95 times 10 to the power 6 times 8.95 times 10 to the power what? Times 10 to the power 6. Everything divided by what? Divided by my mommy. What is our mommy? That is our molar mass. And what there is our molar mass. The molar mass is what? 63.5. 63.5. Now, as usual, simply just do what? We cross multiply, and that gives us what? 635 is equal to, what do you have as base? We multiply everything out. Let's do that quickly using our calculator. So we have it to be 1.6 times what? Times 3 times what? Times 6.02 times what? Then times 8.95. Sorry, that's going to take this time. So we have to be 258. 258.62 times 10 to the power. Let's do the powers. Let's equate the powers. This minus 19 minus 6, that is what? Minus 25. Minus 25 plus 23, that is minus 2. Minus 2, then plus 6, what will that give us? That will give us 4. So here now, what are we getting? You just have your V, which is unknown. So what do you do now? You divide by the coefficient. What is the coefficient? That is what? 258.62 times 10 to the power what? Times 10 to the power 4. You divide both sides by 258.62 times 10 to the power what? 4. This simply cancels this. And what do you have? You have what? You have that V is equal to, divide this by this, what do you have? Just take your 10 to the power 4 out. You know, you have it as 10 to the power 4. When it goes up, it becomes what? 10 to the power minus 4. So what do you have as 635 divided by what? 258.62. That is 635 divided by what? 258. That is point what? 0.62. What do you get? You get 2.45. That is 2.45. That is 2.45. That is 2.455. You can just say 2.46. And what do you have? 2.46 times 10 to the power minus 4 meter per second. That is our what? That is our answer. So this is our answer now. This is our answer. So we just have one more question to solve, and after that question, we end the class. Okay, let's look at this last question. A conductor material has a free electron density. Now, this is what I haven't mentioned in the calculations so far. We have referred to as electron density here now. Electron density is said to be, what's our electron density? That is 10 raised to the power 24. That is electron per watt. That is per meter cube. Electron per meter cube. Okay, you get to understand this better. Okay, let's see. We have other constant there. The drift velocity. What's our drift velocity? We all know that is V. Our drift velocity is 1.55 times 10 raised to the power minus 2. That is meter per second. And the last thing there, which we've been given, is said to be the area. If the cross-sectional area you have to be A is said to be what? What's our cross-sectional area? 1 centimeter square. Don't forget we have to convert this to what? To meter square, and that will give us 1 times 10 to the power minus 4 meters square. Okay. Now the question now is, which of the formula are we to use? The first or the second? I know you'll be thinking of either the first or the second. Okay, we are not using the second, it will still be the first. The reason it will be first here is that, don't forget, we're dealing with electron density here. Now, something interesting here is that the electron density is this ratio that you have like this. That part which I have mapped out is the one talking about our electron density. Definitely, let's use something to represent our electron density. Let's just use something like maybe P. So it means that this P, which is the electron density, it is our number of atoms times the density over what? Molar mass, like money. So if I should take away this part out of this formula, what do you have left? You know your evap Hollandia. So this is evap Hollandia. You have your evap Hollandia. Yeah. Okay, we have our current to be our Hollandia evap. What is E? E is our electric charge, which is 1.602 times 10 to the power minus 19. What's V? That is your what? Your drift velocity. Our drift velocity here is said to be 1.5 times 10 to the power what? Times 10 to the power minus 2 times 10 to the power minus 2. And what do you have as our A? A is our area, which is 1 times 10 to the power what? Minus 4. And the last thing there is our what? P, which is our electron density. What do you have as electron density? 10 to the power 24. 10 to the power 24. So let's get what our current is. We have it to be, just multiply everything out. Don't and you deal with power later. So let's just have that. We have it to be that is 1.602 times what? What do you have? 1.5 times what? Times 1 times what? That is times that is times 1. That is all. I think that is all. Yeah. That has to be 2.4. That is 2.4 times. Let's see what we have. Minus 19 minus 2 give us minus 21. Minus 21 minus 4 will give us minus 25. Minus 25 plus 24 will give us times 10 to the power minus 1. And that is exactly 0.24 ampere. This is our answer. So don't forget, in this particular formula, there is an hidden factor, or hidden parameter, which is called the electron density, and it is your last two parameter and your denominator. So that is all about this electron drift and electric current. If you have any question, you can just send them forward to me and I will answer the questions, and we'll get in touch later. Thank you very much.